Hello everyone. In today's video we shall see some important concepts in electromagnetism, that is Lenz law and eddy currents. With the help of two simple experiments, I will explain you the Lenz law and as well as how eddy currents are produced in the conductors. For doing this first activity, we need one small PVC pipe and as well as one copper tube of equal length. And we drop first the magnets into the normal plastic tube. See, it works as a normal freely falling body because it falls very faster. Now let me do the same experiment with a copper tube. See, amazingly the motion of the magnet got reduced. Let us do it once again. Takes a lot of time. The reason is explained by the Lenz law. Now guess what is the difference between these two tubes? Yes, what you guessed is correct, because one is insulator, one is a conductor of electric current. That means there must be connection between this conductivity of current and this slow motion of magnet. Yes, the currents are produced in this tube. That means copper tube. The currents are not producing in plastic tube. The currents that are producing in this is due to the changing magnetic flux, which is given by Faraday's electromagnetic induction. According to Faraday's electromagnetic induction, changing magnetic flux creates induced current. So when I drop the magnet into the tube, there will be changing flux continuously, and this changing flux creates some induced current, and these currents are known as eddy currents. These eddy currents will produce in such a direction that opposes the motion of these magnets. As it is opposing the motion of the magnets, it is dropping very slowly. So the reason of slow motion of the magnet is due to eddy currents, and these eddy currents produced are opposing this motion of the magnet.
Note that the copper and as well as plastic are non-magnetic in nature. Now let us see Lenz law diagrammatically. This is a copper tube, and the copper tube is a conductor of electricity, but it is non-magnetic. Now let us suppose these are the neodymium magnets we have taken, and we all know that every magnet is associated with magnetic field around it, and magnetic field is represented by magnetic flux. This is the magnetic flux, that means magnetic field lines. Now when we drop this magnet into the copper tube, there will be change in the flux. That change in the flux induces some current. We call this as induced current. And this direction of induced current is given by Lenz law. Let us see first Faraday's law of electromagnetic induction. It states that induced EMF is directly proportional to rate of change of flux. Here the minus symbol is explained by Lenz law. Let us start our second activity. For doing our second activity, we need one small simple pendulum made using one screw attached to the neodymium magnets. Now it oscillates normally, but what will happen if we introduce one aluminum plate? Let us see. I have taken it from an electric rice cooker. See, oscillations are ceased. The pendulum comes to rest immediately. That means something is stopping the pendulum, right? That means some induced currents are developed in the aluminum plate, are creating some magnetic field. That magnetic field is opposing this. So these currents, circular currents that are developed on this aluminum plate, are known as eddy currents. Let us see that with a copper plate. See, the oscillations are ceased, and this is also due to eddy currents developed on the copper plate. Now let us see one of the applications of these eddy currents, magnetic braking in metro trains. Strong magnets, electromagnets are situated above the rails in some metro trains or electrically powered trains. When the electromagnets are activated, the eddy currents induced in the rails opposes the motion of the train. So as there is no mechanical linkage, the braking effect is very smooth. With this, friction is reduced and there is no much pollution also because of this braking. Thank you so much for watching.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.